I'm going to be talking about the sum, difference, half, and double angle formulas. The sum and difference formulas tell us what happens when we take either the sine or cosine of the sum or difference of two angles. For example, sine of alpha plus beta is equal to sine of alpha times cosine of beta plus cosine of alpha times sine of beta. And then for cosine, we have cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha times sine beta. To find the difference formulas, we can simply plug in minus beta for beta. So if we have sine of alpha minus beta, this is equal to sine of alpha plus minus beta. Then using the sum formula for sine, we have sine alpha cosine of minus beta, but cosine of minus beta is the same as cosine of beta, so that doesn't change. And now we're going to have minus cosine alpha sine beta. This is because sine of minus beta is equal to minus sine of beta, so we'll have minus sign here. Similarly, we can find that cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta, since the minus beta on sine beta is going to change it from a minus sign to a plus sign in the second term. Now what if we wanted to find sine of twice of an angle? Sine of 2 theta for some angle theta. To do this, we can simply write it as sine of theta plus theta and use the formula that we had from before. This gives us sine theta cosine theta plus cosine theta sine theta. But these are the same, so we can combine them to just get 2 sine theta cosine theta. And then we can do the same thing for cosine. Cosine of 2 theta is going to be equal to cosine theta minus sine theta sine theta, which is just cosine squared theta minus sine squared theta. Now there are two ways we can simplify this even further. If we replace the cosine squared theta by 1 minus sine squared theta, then we'll get 1 minus 2 sine squared theta. And if we replace the sine squared theta by 1 minus cosine squared theta, then this will give us 2 cosine squared theta minus 1. So now we have several different forms of the cosine double angle formula. Now what would happen if we took one of these formulas and replaced theta by theta over 2? Starting from cosine of 2 theta is equal to 1 minus 2 sine squared of theta, we can get cosine of theta is equal to 1 minus 2 sine squared of theta over 2. Now if we solve this equation for sine of theta over 2, we can find an expression that gives us what sine of theta over 2 is instead of in terms of cosine of theta. Let's try doing this. If we add 2 sine squared of theta over 2 to both sides, and then subtract cosine of theta from both sides, we'll have 2 sine squared of theta over 2 equals 1 minus cosine of theta. And then we can divide by 2 to get sine squared theta over 2 equals 1 minus cosine theta over 2, and then take the square root of this on both sides. So we have sine of theta over 2 equals the square root of 1 minus cosine theta over 2, or rather plus or minus this. If we do the same thing for cosine, then we would arrive at cosine of theta over 2 equals plus or minus square root of 1 plus cosine theta over 2. So these are the half angle formulas. Now that we've added these identities to our collection, we can verify more identities more easily, and we can also use them to explicitly calculate either sine or cosine of other angles that we weren't able to do before.